Oopsies. Let me close one out. Okay. Is this okay? Right now we're going to running a script as a tools. Previous videos we know that scripts can be run in various ways. Running a script as a tool is a great way to integrate Python scripts into ArcGIS workflows. In fact, many scripts written by Esri are made available in tools in ArcGIS toolbox. For example, take the tool at the proximity tool set within the analysis toolbox. Notice that the multiple ring buffer tool is a script tool. So as shown in here, I could just search from here, or I can just go to toolbox, spatial analysis, proximity, spatial analysis, proximity with the P. Okay. It's not alphabetically. Oh. Analyze tools with the A. Right here, proximity. And then multiple ring buffer. Alright. Okay. Now we can see different from the hammer, it's a script tool. And when we double click left hand side twice on the mouse, we open the tool dialog box. It looks like a regular tool with several required and optional parameters. So from the perspective of a regular ArcGIS user, all tools in Arc Toolbox look the same. So, for most system tools in ArcGIS for desktop, the underlying code cannot be viewed. However, for script tools, you can look under the hood by opening the script. To view the contents of a script, we're going to right-click the script tool and then click Edit. So, I'm going to close this out. And then right-click on this and Edit. So here it brings the script tool here. All the scripts are here opened by Notepad. And this shows that the tool calls a script called multi-ring buffer ArcPy. And this script are typically located in I have to see, where did it import ArcPy right here, and where did it call? We have to find the path. I didn't put parameters yet. Script. Let's see, where is the path? Okay. It's interesting to learn. Alright. At first I felt overwhelming right now. I'm still felt overwhelming to learn Python in ArcGIS, but you just have to be patient and learn, and don't worry that you sucks, but you will get better. Alright. The scripts are typically located in the C drive, where your ArcGIS desktop is. But here it didn't specify where the tool is pulling from. Several dozens of the system tools that come with ArcGIS for desktop are script tools, and their content can be viewed in this manner. So the multiple rain buffer pi script that is attached to the multiple rain buffer tool is shown in here. So reading through this code can give you an idea of writing your own code later. Wow. The detail is too lengthy to discuss here. However, the basic idea is that you can create a script and add it as a tool to a toolbox so that it becomes a script tool a user can use without having to work directly with the Python code. So keep in mind that not all system tools are necessarily updated to reflect the latest possibilities in Python scripting. However, the multiple rain buffer script still uses the ArcGIS scripting model. The predecessor to the ArcPy site package. That is why you see the line. I have to see if we have a 9.3 or 10.4 because now it's a little different. I don't see 9.3 anymore. I still have to look into where it is. But we can do a little slowly and say tool name, multiple rain buffer pi author, history company, require argument input feature class or feature layer and output feature class, a set of distance, multiple set of double values, optional arguments. So the name of the field to contain the distant values, the default is distance, option to have the output dissolved, default is all, description creates a set of buffers for the set of input features, and the buffers are defined using a set of variable distances. The resulting feature class has the merged buffer polygons with or without overlapping polygons maintained as separate features. So we import OS and then locate, define something, MS message, get the input argument values in feature equals this, output distance is this, unit is this, file name, and then we have a dissolve type, outside polygon. If outside polygon, side polygon, something here. It didn't mention anything. Classes, ArcPy, try something, buffer, the input for each buffer distance. Okay. Reverse the order. Set default symbology. Finally, if buffer list, if name, okay. So GP locate, and this tool doesn't have a GP thing anymore. It should be here, under here. All right. So it's a lot different than the book. And followed by frequent reference to this geoprocessing object. And Esri does not necessarily update all this code since the tool works fine using the older ArcGIS scripting module. Now, tools that are altered substantially from earlier versions, however, are more likely to be rewritten specifically using ArcPy. And then the script tools that are part of the system tools are read-only and cannot be edited. However, you can copy parts of the script code, or you can copy the script field itself to a different location and make edits to the script. Alright, so now we're going to converting a model to a script. So models and script are analogies in that they are both used to create a sequence of geoprocessing tasks. models can be converted to Python scripts on the Model Builder menu bar. We can do is model export into Python script. And we're going to go over maybe in our exercises, but right now the script contains all the elements from the model. The data input, you can put roads, geohazards, and watershed, and the tools buffer, intersect, and clip tool there. Although a model can be exported to a Python 3 script, however, the reverse is not true. So Python scripts are more versatile than model builders, so that a Python script cannot be exported as a model. Creating a model and converting to a script is a good way to be introduced to what scripts look like and to get familiar with Python syntax. When a model is converted to a script, the Python code very closely follows the elements in the model without adding anything extra. For example, the resulting script does not contain any specific validation or error checking procedures. In general, converting a model provides a starting point for writing a script. So including very specific code blocks, but it really results in a finished script. And we're going to go over scheduling a Python script to run at a script times, so that we have standalone scripts can be set to run as described times. This can be useful for such things as carry out routine data maintenance tasks. The steps for accomplishing this depend on the operating system. So that I have Windows 10. On the taskbar, we're going to click Start button and then Start menu and click Control Panel, Schedule Tasks, and then I can just do Maintenance Schedule Tasks. So and then double click Add Schedule Task, complete the option on the wizard, and then we can put the Windows to Run and Browse button to select Python script. And then many Python scripts require arguments to run. These can set as a part of the scheduled task. On the last dialog box of the wizard, select Open Advanced Properties checkbox. So I do not have anything to run right now. But for a script to run with arguments, the run box needs to be changed to a string that contains the Python executable file, the script, and the arguments to be passed to the script. For example, this will look like some code, C Python 27 python.exe, and put text script, py, and data streams .shapefile. And these arguments are similar to the way parameters are passed to a script from a script tool. If all information needed to run the script is hard-coded in the script itself, no arguments are needed. Scheduling a Python script to run at prescribed times appears relatively simple, but there are some potential obstacles. First, the computer needs to be turned on for all a scheduled task to be executed. Second, scheduled tasks typically require administrative access, and login information needs to be provided when the task is set up. Finally, many Windows-based PCs are configured to be locked or to log off current user after a certain period of interactively, which can interfere with running scheduled tasks. So before you can rely on scripts being run in this manner, it is worthwhile to test your computer configuration to ensure scheduled tasks are run properly. Anyway, some key points we're going to summarize here. The dual processing framework in ArcGIS provides a powerful yet flexible system for organization and running tools. ArcGIS has a large number of tools organized in toolboxes and toolsets within Toolbox. The different types of tools include built-in tools, script tools, model tools, and custom tools. A tool is run by specifying tool parameters including input and output data sets, and other parameters that control how a tool is executed. Environment settings also control how tools are executed and can be set at different levels. You can create your own tools using model